Hi, welcome to Keys Consumer Math and Personal Finance, Section 1.1, Rates, Ratios, and Proportions. Everything in this section you have learned in a previous math class, but it is foundational to consumer math, so we will review it here. We're going to begin with the definition of a ratio. A ratio is simply a comparison of two numbers or quantities. For example, I can compare the number of girls to boys, or I can compare the number of cats to dogs, or the number of green apples in my basket to the number of red apples in my basket. That's all a ratio is, just a comparison of two numbers. But it's written as a fraction, so you can consider a fraction as a ratio. In fact, if you remember from your previous classes, a rational number is a fraction. And if you look at the word rational, the root word is ratio, because it comes from the word ratio. So if I were to compare, let's say, the quantity of A to the quantity B, I could write it in three different ways. I could write it as I say it, A to B. Or I could write it with a colon between them, A colon B, but I would still say A to B. Or I could write it as a fraction, A on the numerator, 2, which is the fraction bar, which is also a division symbol, to B. The first number that I say, A, goes on the numerator. The second number that comes after the word 2 goes on the denominator. An example of this would be if I were to compare the number of girls in my family to boys in my family. So in my family, the number of girls is 3, and the number of boys is 4. So if I were to compare girls to boys, then I would write it as 3 to 4, or more commonly as 3 over 4. If I were to compare boys to girls, then the boy would come first, the number of boys would come first, which would be 4, then the number of girls to 3, or 4 over 3. I could also compare the number of girls to the entire member of the family. So I could say there are 3 girls for every 7 members of the family. So 3 plus 4 is 7. That's where that number came from, or 3 to 7. I could do the same thing with boys. I could say 4 boys to every 7 members, or 4 to 7. Now I would like for you to pause your video and look on page 2, study example 1, and then come on back. Welcome back. The next definition we're going to look at is rate. Rate is simply a ratio that compares two quantities with different kinds of units. For example, what if you wanted to compare how far you drove to how long you drove? Then that would be a ratio that could be expressed as a rate of miles per hour. Miles is a unit of distance, hour is a unit of time. They are different units, and therefore they're considered a rate, because a rate is a ratio that compares two quantities with different kinds of units. Other examples are how far you may go on a gallon of gas. That would be miles per gallon. Or how fast you can type your words. That would be words per minute. Now let's work on an example of how to simplify ratios. Let's say that we had a book that had 140 pages in it and 78,400 words. How would we find the rate of words per page? First, I would write my ratio. I would write words per page, so I don't get mixed up on what numbers go where. Now, I see that there were 78,400 words, so I'm going to write that on the numerator. And I'm going to write how many pages there were on the denominator, 140 pages. And then all I have to do is simply reduce. And reducing is just dividing. 78,400 divided by 140 is 560 words per page. That is just a simple example of how you reduce or simplify a rate. I'd like you to pause the video now and go study example 2 on page 2 of your book and then come on back for the next section. The last section that we're going to study in this section, or the last concept, that we're going to study in this section is proportion. Proportions are simply equations that state that two ratios are equal. In other words, the ratio A to B is equal to the ratio C to D, and that is read A is to B as C is to D. Now the red numbers, A and D, are called the extremes of the proportion. They are the first number of the first ratio and the last number of the last ratio. And the blue numbers, B and C, the ones in the middle, are called the means. Think of the average as being in the middle, and mean means average. So we've got extremes and means. So if you've been told to solve a proportion using extremes and means, this is what it's talking about. And I'm going to show you how it works. If two ratios are actually equal, then the product of the extreme equals the product of the means. What that means is if I multiply the extremes together, A and D, their product, or the answer to that multiplication problem, is AD. If these two ratios are equal to each other, then B times C will also equal A times D. Now, when I was a kid, my teacher taught me how to do this. It's silly. I never forgot it, though, so I'm going to teach it to you. If you've got two fractions or two ratios that are set equal to each other, a proportion, you can solve it by cross-multiplying, or my teacher said the bird flies up. So the bird flies up, he hits the wall, and he falls down. He collects the extremes, D and A. So A times D. And then the bird does it again. He flies up, he hits the other wall, and he falls down. And collects C and B. So A times D equals C times B. Here's an example. Is it true that 1/2 is equal to 2/4? Well, I can check this by using extremes and means. 4 times 1 gives me 4. Is that equal to 2 times 2? Well, yes, 2 times 2 also equals 4. Therefore, because the product of the extremes equals the product of the means, these two ratios are proportional to each other. Let's look at an example in your book. If you look on page 3, let's look at example 3. It says the ratio of female to male employees in a large department store is 8 to 3. If this holds true for the entire mall and there are 600 women workers, how many men work in the mall? So we know, I'm going to write my words so I don't get confused. I'm going to write women to men. Now I know that there are 8 women for every 3 men. That's my first ratio. My second ratio is, I know in the mall there are 600 female workers, but I don't know how many male workers there are, so I'm going to call it X. And this is how we use proportions to solve for missing numbers. So I'm going to cross multiply. X times 8 is 8x. 3 times 600 is 1800. And then I'm going to divide both sides by 8 because I want to isolate x. And to undo multiplication, 8 times x, I have to divide. So 8 divided by 8 is 1, and I'm left with just x. And then 1800 divided by 8 is 225 men. And that is how you use extremes and means to solve for a variable. I would like for you to pause the video and look at example 4 on page 4 and then come on back. Let's do some examples together. Please write these in your notebook, and anything that we do not finish together on the video, I'd like you to finish on your own and show me in class tomorrow. Let's do the first problem. It says solve for x, so I'm going to use cross multiplication. I'm going to multiply 8 times 35, and when I do that, I get 280. And then I'm going to multiply 15 times x. And I'm going to get 15x. And now I'm going to solve for x by dividing both sides by 15. And when I do that, I get x equals 18.7. Let's do the second one. 2 times 14 is 28. X times 7 is 7x. When I divide both sides by 7, I end up getting x equals 4. And this is how you solve these problems. Please pause the video and solve problems 3, 4, and 5 on your own. Let's do problem 6 together. Alright, a plant nursery grows snapdragons and carnations in the ratio of 2 to 5. How many carnations are there if there are 230 snapdragons? So the way I'm going to do this is I'm going to write, I want snapdragons to carnations, so I'm just going to go ahead and write those variables just to make sure that I don't get things mixed up. And let's see, we know that there are 2 snapdragons for every 5 carnations because it says snapdragon to carnation, so 2 to 5. And now, I know that I have 230 snapdragons, but I don't know how many carnations I have in proportion to that. So I'm going to put an x. And then I'm just going to solve by using means of extremes or cross multiplication. X times 2 is 2x. 5 times 230 is 1,150. And then when I divide both sides by 2, I end up getting 575. So I know that I have 575 carnations when I have 230 snapdragons. Okay, let's try to do number 7 together. It says a zoo has panthers and ocelots in the ratio of 3 to 2. How many panthers are there? Excuse me, if there are 4 ocelots, how many panthers are there? So we know that we've got panthers to ocelots. Panthers in the ratio of 3 to 2. It says if there are 4 ocelots, so now I'm going to put my number, my 4 down here, because I know that's how many ocelots I have. I do not know how many panthers I have, so I'm going to put my variable on the top. Again, I'm going to cross multiply. 3 times 4 is 12. 2 times x is 2x. And if I divide both sides by 2, then I end up getting x equals 6. So there are 6 panthers in the zoo. Now, I would like for you to try number 8 and 9 on your own, but we're going to look at number 10 together because it's worded a little differently. It says in Krakatoa, the most deadly volcanic eruption known, resulted in a death toll of in 1883 of about 632 times that of the 1980 eruption of Mount St. Helens. 57 died in the Mount St. Helens eruption. About how many lives did Krakatoa claim? Well, this one we don't have to set up as a proportion because it tells us that there are 632 times the death in Krakatoa as there were of Mount St. Helens. So all I have to do is multiply 632 times 57. Sometimes problems are very straightforward and we don't have to make them complicated. So, but that sometimes confuses us too, so I don't want y'all to get confused with this. So anyway, if I multiply 632 by 57, I get about, not exactly, but about, because this is about 36,000. I think it's like 36,024 people died in Krakatoa. Go ahead and finish these extra problems and show them to me tomorrow. You'll have a good evening.